Hello?
Hello, Neo. Do you know who this is?
Morpheus.
Not like the year of Neo in Matrix, so many people use cell phones and want to transfer their data to one another. Obviously, we need more space to use the signals. How do we transfer data without loss? The answer is using OFDM, which is a method of encoding digital data on multiple carrier frequencies. The main concept in OFDM is orthogonality of the subcarriers. The orthogonality prevents crosstalk between subcarriers. So, let's look at what orthogonality is.
Orthogonality has Greek roots from the words orthos, meaning straight, and gonio, meaning angle. Together, orthogonios means right-angled. Two perpendicular lines intersecting at right angles are considered orthogonal. Let's look at the mathematical definition of the term orthogonal. Two vectors are called orthogonal if their inner product is zero. We also have a definition of orthogonality for functions. Two non-zero functions f and g are considered orthogonal over an interval if the integral of f times g evaluated over that interval is zero.
Let's look at some more examples of orthogonal vectors. Consider the set of vectors in R3. Choose a basis for this space. Note, the inner product of each pair of these vectors is 0. This is an orthogonal basis for this space. Let's look at a practical example, RGB, or red, green, blue color space. Let's represent these colors as simple vectors in R3. Here is an orthogonal basis for this space. What might a non-orthogonal basis for this space look like? Here's one example. Verify that the inner products of these vectors are all non-zero. These colors look familiar. They are actually the cyan, magenta, and yellow of CMYK color space, used for color printing. We can represent a color in CMYK space as a vector of this form. In this coordinate system, these vectors are orthogonal. Note that without black, we cannot span the space.
So, are there any questions? Yes, you over there? Did you just ask me how you can find more information about orthogonality? For more information, go to www.google.com and search orthogonality.